Dear learners, welcome to the video lesson on the topic Silicones. I am P. Bhanuprakash, lecturer in chemistry from SUCR Government Degree College, Palamner. Learning objectives. Through this video lesson, we are going to discuss about the following topics. Introduction to silicone, types of silicones, preparation methods of silicones, and finally about the applications of silicones. What are group 14 elements? Carbon, silicon, germanium, tin, lead, flerovium constitute group 14 elements. Let us see the outer electronic configuration of these group 14 elements. In case of carbon, the outer electronic configuration is 2s2 2p2, silicon 3s2 3p2, germanium 4s2 4p2, tin 5s2 5p2, lead 6s2 6p2, flerovium 7s2 7p2. Hence, the general outer electronic configuration of these group 14 elements is ns2 np2. They have 4 electrons in their valence shell and hence they can form tetravalent covalent compounds. Carbon is a non-metal. Silicon is a metalloid. Germanium is also a metalloid. Tin and lead are examples of metals. Silicon is the second most abundant element in the earth crust after oxygen. In nature, silicon is available in the form of silicates and silica. The silica is the main ingredient of the sand. In the picture, you can see the silicon in its native state. Silicon is one of the most important constituents in the industrially important materials like glass, ceramics and cement. Silicon, being a metalloid, is used as semiconductor in computer and mobile phone integrated circuit chips and also in transistors. They are also used as semiconductors in solar cells and solar panels. What are silicones? Organosilicon polymers containing SiO-Si linkages are known as silicones. Silicones are also known as polysiloxanes. The repeating monomeric units in silicones are R2Si, bond O, bond SiR2. The general formula of silicones is R2SiO taken n times. Here R is an organic group like methyl, ethyl or aryl group, etc. Let us see the classification of silicones. Silicones are broadly classified into 3 types. Number 1, linear silicones. Number 2, cyclic silicones. Number 3, cross-linked silicones. Let us understand the different preparation methods of silicones. The preparation of silicones involves 2 steps. Step 1 involves the preparation of mono, di or trialkyl substituted silicon chloride intermediates. Step 2 involves the hydrolysis of intermediates prepared in the step 1 followed by polymerization to give silicones. Firstly, let us discuss about the preparation of intermediates. The intermediates required for the silicone preparation are alkyl or aryl substituted silicon chlorides. They can be prepared by the following 2 methods. The first method is the reaction of alkyl or aryl chlorides with the silicon in the presence of a metal catalyst like copper. For example, the methyl chloride with the silicon in the presence of copper catalyst at high temperature gives methyl trichlorosilane, dimethyl dichlorosilane, trimethyl chlorosilane derivatives. All these 3 derivatives are very close in their boiling points, hence they can be separated by using the technique known as fractional distillation. The second method to prepare the reactive intermediates for the preparation of silicone is through the reaction of silicon tetrachloride with the alkyl magnesium halide, that is Grignard reagent. We know that Grignard reagent is a good nucleophilic reagent. For example, the methyl magnesium chloride reacts with silicon tetrachloride to give methyl trichlorosilane. Here, one Cl group is replaced by the methyl group. Similarly, the methyl trichlorosilane reacts with one more molecule of methyl magnesium chloride to give dimethyl dichlorosilane. This dimethyl dichlorosilane again reacts with methyl magnesium chloride to give trimethyl chlorosilane. This trimethyl chlorosilane again reacts with one more molecule of methyl magnesium chloride to give tetramethylsilane. Let us discuss about the preparation of linear silicones. The intermediate that is required for preparation of linear silicone is dimethyl dichlorosilane. This on hydrolysis gives dimethyl silane diol. These dimethyl silane diols polymerize with the loss of water molecules to form linear silicones as shown in this picture. Here you can observe that two molecules of dimethyl silane diol lost water molecule to give this monomeric unit. These monomeric units polymerize with loss of water molecule to give linear silicones. The chain length of these linear silicones can be controlled by addition of trimethyl chlorosilane. In the picture you can clearly observe that the two molecules of trimethyl chlorosilane will react with the terminal OH groups of linear silicone so that you will get the controlled chain length of linear silicones with the loss of HCl molecules. Let us see the preparation of cyclic silicones. Cyclic silicones are formed by the elimination of water molecules from the terminal OH groups present in the linear silicone. This is a linear silicone with the terminal OH groups. From here, the water molecules will be lost to give the cyclic silicone. Let us understand about the preparation of cross-linked silicone. The intermediate that is required for preparation of cross-linked silicone is methyl trichlorosilane. This on hydrolysis gives methyl silane triol. This methyl silane triols polymerize with the loss of water molecules to form cross-linked silicones as shown in this picture. Here you can clearly see this methyl silane triols polymerizes with the loss of water molecules to give cross-linked silicones. In cross-linked silicones, you can observe the SiO-Si linkages in the horizontal direction as well as in the vertical direction. Let us understand the properties of silicones. Silicones of short chain length are oily liquids. Silicones of medium chain length are viscous liquids and greases. Silicones of higher molecular weight, that is long chain length, behaves as resins and rubbers. They are highly resistant towards heat and as well as they are inert towards chemical reactions like oxidation. Due to the surrounding nonpolar alkyl groups, they are water repellent in nature. Silicones or polysiloxanes are having good electrical insulating properties. Let us discuss about the applications of silicones. Depending upon the degree of polymerization, silicones are manufactured and used in the following forms: silicone oils, silicone rubbers, silicone greases, silicone resins. In the picture you can clearly see the silicone paste and the non-sticky molds which is made up of silicone rubber. Let us see the applications of silicone oils first. The low molecular weight straight chain silicones of 20 to 500 repeating units are used as silicone oils. They withstand high temperatures and they are chemically inert. Hence they are used in manufacture of paints and enamels. These silicone oils are used as hydraulic fluids, brake fluids, transformer oils, and they are also used in oil baths that require high temperature. They are also used in high vacuum pumps. The emulsions of these silicones are coated to textiles, paper and other materials to give water repellent properties. These silicone oils or fluids are used in car polish and shoe polish. Let us see the applications of silicone rubbers. Silicone rubbers are made up of high molecular weight straight chain silicones between 6000 to 6 lakh repeating units. The elastic nature of silicone rubbers does not vary at even low temperatures like up to minus 90 degrees centigrade or even up to high temperatures of plus 250 degrees centigrade. Hence, the silicone rubbers are used as good insulators in electrical appliances. They are also used to seal joints of jets of aircraft and they are also used as soles of inner boots of astronauts. Silicone greases. They are made from mixtures of silicone oils and fillers like lithium soap, silicone, carbon black. They are used as high temperature lubricants in high speed ball bearings in aeroplanes, and they are also useful for low temperature lubrication. The silicones with phenyl substituents act as better lubricants. Silicone resins are rigid and extensively cross-linked silicones. The properties of the silicone resins depends on the nature of substituent on the silicone. The phenyl groups on silicone increases the resistance towards heat. The methyl groups on the silicone gives more flexibility. The ethyl groups in silicone resins increases its water repellent nature. Silicone resins are used for lamination, non-stick coating on metal surfaces as well as electrical insulating materials. Summary: organosilicon polymers containing SiO-Si linkages are known as silicones. We also learned that silicones are of three types: linear silicones, cyclic silicones, cross-linked silicones. We discussed about the preparation methods of silicones. We also learned about the properties and applications of different silicones. Thank you.